So let's dive into the container service. How does it work? What makes it work? And how does it integrate with XNAT? First, let's go through some terms of art here, and a caveat up front. You'll see the term Docker in these slides quite a lot. And that's because we built the XNAT container service around Docker technology to start out with, but we are also exploring the possibilities of making this same technology work in other platforms, such as Singularity or Kubernetes. But for that said, let's just focus on these terms here. Every container service for XNAT relies on a server that has an engine that can run containers for you, and you have a hub that holds images, and this hub can be either a public hub like Docker Hub, or it could be a privately hosted repo for images that you don't want to widely distribute. And then, of course, the container execution. This spawns up a temporary instance of the image, its environment, and runs commands for you. And so a simple workflow, and when I'm not talking about working with XNAT at this point. So this is a user with data in hand sitting at a computer terminal, and they are accessing their Docker server. So the simple workflow starts with pulling down an image from your hub or your repo and installing it on your Docker server. And you do that by executing a simple command, say docker pull this image from this repo and get an image with this particular version tag associated with it. The server takes that instruction and it goes and retrieves the image and installs it into the server. So how does an image get created? What's in it? The contents of an image are defined by the Docker file, and this defines what is your runtime environment, what kind of dependencies are necessary. So let's say you were containerizing a Python script. The first thing you would do in your Docker file is define the Python environment that you wanted this to run in. This would be what version of Python and what libraries you need as dependencies. And then you have executables. So this would be the Python script as an example, or some other executable that will run the command that you want to run. And that executable will have parameters that you can set, etc. And there may be other resources as well. The Docker image is a machine image. It can hold all kinds of different resources as needed. So one example of this might be a specific executable like MATLAB that requires its own private licensing. You could include that licensing as a resource in the image. You know, this kind of image you wouldn't distribute widely because the licensing is site specific, but you could distribute it to terminals within your site. And so a simple workflow for launching a container, again, you've got your user at your terminal with data in hand. They would type in a command and say docker run, and then specify what process they want to run, what options up front are necessary, where your files are located, and what parameters to run this command with. And this command gets sent to the server. So at this point, your Docker server is ready to launch a container. What it does is it goes into your file mounts and it gets the files that are submitted for this job, and it takes the inputs and it puts them into the container with an instance of your machine image, and it runs the executable using the parameters that you defined. And after the executable runs, an output of some sort is generated and returned, whether that's a new file or a report or a log or whatever. And that output can be sent back to your file mount on your local file system. And the magic of containers is that this process will run exactly the same way in exactly the same environment every single time. So unlike traditional compute environments, and this includes the XNAT pipeline engine, maintaining the server and maintaining the environment at a specific state is integral for managing long-term research. You can't really make updates to that server without validating that those updates haven't changed the functioning of your executable in some way, and thus changed or possibly invalidated the data that you collected up to that point. Whereas in a containerized environment, the container acts as a virtual shell around the runtime environment that ensures that it will always run exactly the same way every single time, regardless of what happens with your Docker server, regardless of what happens with any of your other computing environments. That container will always remain the same. And that is the key for reproducible science. If you want to run the same process on differing data, or if you want to give your process to somebody else for their comparative research, they can spin up the exact same environment and run the exact same commands as you are on their data. So how do we integrate this with XNAT? Because the goal here is to get that reproducible science workflow and apply it to XNAT data. The left side of our diagram is more complicated now. Our user is no longer accessing the Docker server directly. They're working through the XNAT UI. And so what they're doing is they're connected to the XNAT server, and the server has access to your Postgres database where your experiments are stored, and the file system where all your file resources, your scan files, etc., are stored. And the XNAT server is running a container service plugin, and that is what manages the connection between XNAT and the Docker/container processing environment. So to kind of recreate our simple workflow here, when a user wants to install an image, they type a command into the UI, or they fill out a form in the UI and specify pull this image from this repo with this tag, just as you did before. And then when they click submit in the UI, the container service plugin translates that action into the Docker parlance and feeds the command to the server. And the server contacts the image hub, pulls down that image from that repo with the version tag associated with it, and installs it. But the difference in this case is that we want to install an XNAT enabled image. And so what does that mean? An XNAT enabled image is built in much the same way as a normal Docker image, but it has all the same stuff defined by the same Docker file, but now it has more stuff. It has new stuff that is XNAT specific. And we call that the XNAT command definition. And what this does is it connects the elements of the image, in particular the executable. What's your command line argument? What's your Docker run argument? Here are all the elements of that argument, let's connect it to your XNAT. So, where do I find data mounts? Where do I, what kinds of inputs are expected? What kinds of outputs are expected? And then how do we expose these things in the UI? And in what XNAT context is this exposed in the UI? So, for example, if I have a process to convert a DICOM scan to Nifty, then let's make that available to the MR scan data. So, going back to our workflow here, how would a user in XNAT run a container? The UI now has this context-aware menu, and it will say, oh, you're looking at MR scans. Here is this process that you can run. Here is this command that you can run. And so the user is given a menu option to say run container. And let's run this container on these 2 scans in my session. And again, if you click OK on that in the UI, the container service plugin manages the interaction with the Docker environment. So it mounts the scan resource files. It uses the API to communicate with Docker, send inputs to the Docker server, and spin up a container which will execute that command and return outputs back into your XNAT. Where things really start to get fun is when you start thinking about batching operations and running them in bulk. Because running a process on 1 or 2 scans at a time is fine, but it's obviously a lot more powerful if you can take that same process, batch it up, and run it on every bit of data in your project, or every scan that matches certain search criteria. Now, in order to handle this, you need a different kind of processing output on the right side of our diagram. A simple server would choke on a request like that. So what you need is some way of parceling out those jobs. And in the Docker world, this is referred to as a Docker swarm, where you have multiple processing nodes attached to your server, and you have a central queue management service. So if I send a whole raft of jobs to the Docker server in swarm mode, those jobs get queued up, and then as processing nodes are available, containers are launched in bulk on each node in batches of 5, 10, 20, however many can be handled based on how much memory your command uses and how much memory is available in that processing node. And so each one of these jobs is now monitored, and as they complete and data is fed back into XNAT, we can see that in the UI. So that's our introduction to the key concepts of container service. Let's dive a little deeper with some practical exercises.